So when you're graphing cosecant, which is this graph right here, what you have to realize, the reason it looks kind of funky, is you're taking the reciprocal of sine. And what that looks like mathematically is reciprocal of sine is right there. You're taking and flipping every value of sine, every output of sine. So let's graph sine on this cosecant graph. So sine would look like this. If you think through what sine looks like, there's sine. Now, and if you think about what a reciprocal means, it flips the value. So that kind of what it does is it flips the graph as well. Meaning, for sine, your value is 0. The reciprocal of 0 is undefined. So there's an asymptote here. All right? At 0, again, the reciprocal of 0 is undefined. So an asymptote and an asymptote. Now, the value here is 1. The reciprocal of 1 is 1. That's why it's still there. Same thing here. The reciprocal of -1 is -1. And then if you take each value here, what happens is you're taking the reciprocal, so it kind of just flip-flops. So basically, to graph this, you graph sine. Everywhere there's a 0, you graph an asymptote. And then you just draw a parabola-looking shape right there, which flips it. It's kind of nice, kind of quick. All right, let's graph cosecant x over 3. First of all, you have to realize we're going to graph sine of x over 3. All right, to graph sine of x over 3, we have to look, okay, well, your amplitude is 1, your midline 0, but what is your period? This messes your period up. So my period is going to be 2 pi divided by a third. So remember, like a 1 right here. When I do 2 pi divided by a third, that's 2 pi times 3, so it's 6 pi. So what we have here is this. We're going to graph a sine graph that goes to 6 pi. Half of that will end up being 3 pi. And then we're going to go up and down the normal 1 because there is no amplitude on this, so it's just 1. All right, so let us graph sine. Halfway between, you'd be going up, and halfway between, you're going to be going down. So we're going to graph a dotted sine graph. Because sine is not the graph, it's going to be the reciprocal of sine. All right, then we have to remember, okay, wherever it's 0, the reciprocal of 0 is undefined. So we're going to have asymptotes here, here, and here. Vertical asymptotes, that is. So we're going to put some vertical asymptotes right here. Put another one right there. And lastly, right there. Those are some vertical asymptotes. And then I put the graph of the reciprocal. So I'm going to hit right here. All right, I'm going to hit right there. And then I'm just going to up across next to the asymptotes and back up. That would be the reciprocal of that interval. And here, we hit that dot. That stays -1, because the reciprocal of -1 is -1. And then we put the little shape inside of those asymptotes. And we are done. That right there would be the graph of the secant x over 3. So we're going to graph this one right here. Well, the only change this has is it has a -2, or a 2 amplitude, and negative means flipped. So it's going to be amplitude of 2 flipped. So we're going to first graph, like always, sine. For cosecant, you're going to graph sine. So our period, since it's not been changed, is simply 2 pi for sine, which means pi is in the middle. And then our amplitude, we're going to go up and down 2. So that'd be a 2 and a -2 because of that right there. All right, so let's draw sine. All right, remember it's upside down, so we're going to draw an upside down. So we're going to start here. We're going to hit here and end here. We're going to go halfway through, we're going to go down, and halfway through, we're going to go up. So again, this is the dotted graph because this is not the graph. This just helps you graph it. Next, we want to put the asymptotes. Remember, asymptotes, wherever it equals to 0, is going to be a vertical asymptote because the reciprocal of 0 the reciprocal of 0 is undefined. And then lastly, we're going to graph it. So the reciprocal of -1 becomes -1. And then it flips over, does a reciprocal look. And then the reciprocal of 1 is 1. And then we graph it right there because all my values get flipped. And it ends up looking like that.